Hi, my name's John. I hope you've all had a good Christmas. I hope all your families have enjoyed themselves and everybody's well. I've certainly enjoyed my Christmas, I've enjoyed my time off work, and I've also enjoyed what time I've had in the shop. I come into the shop on Christmas morning. There was no new milling machines or shaping machines, but what I did get, the wife got us some jumpers made. They've got the Twisted Engineering logo on the front and the double boost across the back, which I thought was very thoughtful of her. I've spent a fair bit of time on YouTube, as you do when you're on holiday. I found a channel, a lad called Halligan142. He's got a good channel, he does similar things to me. He made a tool for finding the centre of a bit of flat bar. The tool's not his idea, it's an old idea, but the way he made it was quite clever. He obviously hasn't got a milling machine, so he used his lathe cross slide to accurately position the 3 holes. I've made my own version of it. I've got a milling machine, so I used that to do the holes. It's brilliant the way it works. Suppose you wanted to find the centre of that bit of box section, you simply put the tool on, turn the 2 dowels till they touch, centre mark, and that's your centre. If you turn it round, do it again, the 2 holes are dead in line, so you can test it for accuracy. It's the same as doing like a spirit level on how we test a spirit level. It works on any flat material that'll go in between those 2 pins. You can make a bigger one or a smaller one. Anyway, I've spent a bit of time making this. I've probably gone a bit over the top on it, but it's something I've made for myself. And when I do things for myself, I like to finish them off nice, spend a bit of time. Anyway, the rest of the video will show you how I went about making it, drilling the holes. The pins were interesting. They're actually hardened steel dowel pins. I softened them, machined a point on them and retempered them. That's worked quite well. Anyway, right, I found a bit of 3/4 inch key steel. I think it's 3/4 inch. 3/4. Bit of 3/4 key steel. I'm going to use this for the main body. It's just about 4 inches long. We need to make it 4 inches long. The only critical dimension on the whole job is the position of the 3 holes. They must be evenly spaced, one on each end and one exactly in the centre. They can be any distance apart as long as you have one exactly in the centre of the other 2. I'm going to make mine 3 inches apart and one in the centre. You can make a bigger one for bigger bits of metal or a smaller one for smaller bits of metal. It just so happens that I found a bit of key steel 4 inches long, and that's what I'm going to use. And obviously I've got to drill holes in there. It's no good putting it in the drill in the vise. You'll drill down and you'll damage your vise. It needs packing up. To pack it up, we use things called parallels. I've got a couple here. I don't actually bought ones, I homemade ones. What it was, a friend of mine had a bit of it there. He had a vertical height gauge, a vertical vernier. The head was broke on it, and that's a nice bit of ground steel. I used that, I've cut it up and made parallels with it. You simply go in your vise like that. Your job sits on top of it. You put a nip on. Give it a little bit of a bed down with a rubber hammer, nip it up, and you're able to take the parallels out. That's held in place so you can drill right through without damaging your vise. What I'm going to do, I'm going to face one end first. For that I'm going to use an end mill. That's not the way to do it. That's a chuck for drills, for drilling holes, not for holding end mills. You've got all that distance there, wobbling about, no good. You must put the milling cutter into a cullet so it's held right up tight. Obviously the more distance you've got from there to there, and your bearings are up there, you're putting more load on. It's just a lightweight machine. Everything must be kept nice and short. Put a cullet in there, milling cutter in the cullet. Drill chuck, drilling holes. Right, take the chuck out. Quite a handy tool, you'll have seen it before. It's just a socket, 18mm socket, bit of steel tube with some copper in the end of it. Copper's ideal for knocking the top of the drawbar. We'll cut it, cut it. There's a 10mm collet goes in there. I've got a lot of milling cutters. I've got half a dozen carbide ones, and I use them all the time. That's a carbide one. All I want to do is square up the end of the bar. So our cutter's going to be going clockwise in that direction, and our feed's going to be going in that direction, which is conventional milling. We're going into the direction of cutting. You can do this a lot faster, take much bigger cuts, but you have to start putting coolant on. For the sake of doing the video, I don't want to put coolant on. Cutting that quite happy there. You can see it's put a reasonable finish on. It turned it round. All we'll do is square it up and then measure it. Getting a reasonable cut, but not a massive cut because I haven't got any coolant on it. You can get away with a lot of carbide. When I've got the camera set up here, I'll show you what's meant by climb milling. I'll put a cut on, and we'll feed it in the other way so the cutter's dragging the job in. You can feel it pulling it in. It's actually easier to cut, but it's putting a shade finish on compared to conventional milling. I'm having to actually pull the job through the cutter there. It's much smoother. It puts a much better finish on. You can get away with climb milling, but you need a much bigger stiffer machine than this. I'm getting near now. Put my clamp on, vernier. It's 40 thou to come off it. Zero DRO. Put a 20 thou cut and then measure it again. The size isn't that critical, but I might as well make it to ear size. It's always good practice. And that 20 thou, that'll be down to 4 inch. If it was super critical, you would actually lock the table off. Dead on 4 inches. Right, I've done no marking out at all on the job. I'm going to mark it out as I go along using the DRO on the mill machine. Like I say, there's only 3 critical dimensions really. That's the 3 holes, one each end and one in the centre. As long as that centre hole is in the centre of the other 2, it will work. What I'm going to do, I'm going to find the centre of the bar first so I can drill my holes. Use my edge finder. I'll try to get the DRO into shot as well so you can see how it works. Start it up. Put the same glasses on. Gently fetch it towards us until it touches. You can see it sort of, the bearing slow down and stop. I've done videos on this before. It's just touching there. So for 0, when Z axis at that, take it on the other side. I could use maths to work this out, but if you do it this way, you can't go wrong. Right, indicate it just touches. Just touching there. We've got a reading at 1.6592. .659. Right, stop that. Calculator. You don't need a calculator, but it's easier. Memory giveaway. Right. 1.659 divided by 2 equals 0.8295. Okay? So 0.82 0.8295. Lock off that y-axis right in the middle. Right, I'll zero that, then I can always go back to it. The next thing I need to do is to find the end of the bar. I'll just derag it into the bar where the cutter went off the end. Right, so we need to find the end of the bar. You can see the bearing there, you can see the paint marks on the bearing. Start the machine up, wind it along until it just touches, which is there. Doesn't quite stop, but it's actually touching. A little bit of friction on it. Right, start the machine at that. Right, so if we look at our screen, we can zero our x-axis. Let's take the table down a bit. Right, now I know for a fact that half of that bearing is 0.490. So if I wind this to me, 490,000. 490. That is exactly on the edge of the bar. So we can zero that again. Right, so I zeroed my y-axis for the centre of the bar, and my x-axis is zeroed for the end of the bar. It'll float a tenth, 2/10 either way. So now I want to go in half an inch, drill a hole, inch and a half, drill a hole, inch and a half, drill a hole. Then we should have our 3 holes evenly spaced. One of the reasons I use the dowel pins is I've got a reamer the right size, an 8mm reamer and a 7.9mm drill. First thing we need to do, centre drill. Put a centre drill in. So right on the edge, it's 0. So we need to come in half an inch. Right, half an inch. What I'll do, I'll lock the table off. Right, 1/2 inch, table's locked off. Put a centre drill mark in. A little bit of oil. Put a pilot drill through. Machine's nice, this case steel. Right, and we're in over 7.9mm drill. Try a pin in there. The pin won't go in. Right, you get me a reamer. Pin goes in just nice. What I'll do, I'll Loctite the two outside ones in the centre one where a punch goes, that'll be free to move. Right, so when that loosened off, I'll zero the x-axis so I haven't even got to think about it, and it's 1.5 inches. Inch and a half, lock it up again. Centre drill, 7.9mm drill. Nice and gently, plenty of cooking oil. Possibly run slightly fast for doing this, but it's good to no problem at all. So the drill's purely and simply kept for use with that reamer. It lives in a box with a reamer. Plenty of oil on the reamer, nice and gently. One thing with the reamer, you mustn't turn it backwards. You're reaming by hand, you don't turn it backwards, blunts them. Right, so I can zero that again, another 1.5 inches. Loads of oil, really gently. So we've got 3 nicely reamed holes which are exactly the same distance apart. Bastard. Come on man, you fucking snivelling twat.